Hello, hello, hello. I'm very excited to bring you a game that I have been excited about for a few years, that I finally developed in 2019, and that I think we can do possibly digital in 2021. And that game is a play on war. Now, those of you who have played card games before might have remembered that war is just a game of you go back and forth with cards, flipping them upside down, and whoever has the highest number gets both cards. The winner of that game is chosen by whoever gets both decks. So essentially the person that ends up having, the 104 cards wins, or if you play 26-26 and you split it. So really quickly, I want to explain how we're going to do that with chemistry. First off, in class, what we would have done is everybody would have got a master deck. This master deck contains the same set of 9 cards. So all these contain the same set, and those are argon, chlorine -1, sulfur -2, phosphorus -3, silicon -4, and the list goes on. And again, there are 9 of them. The reason why is because, as some of you probably can imagine where we're going with this, seeing the ion symbols, it's based on the number of electrons. So your number of electrons will determine who wins. So, 1, you might want to get a periodic table handy. And 2, those of you who are doing this in the Google form version, right below this video will be a periodic table for you, okay, as a quick review. And you might have noticed what's similar about all these. And you guessed it, it's the electrons. Argon is element number 18 and has 18 electrons. Chlorine is 17, potassium is 19. However, chlorine with a -1 charge means you have gained 1 electron. 17 plus 1 is 18. This is a tie. Potassium, 19. But with a +1, you have lost 1 electron. 19 minus 1 is 18, also a tie. So all of these pieces invoke ties in the game. So really quickly, how does that work? Well, what happens in a game of war, let's say that you have these cards. Let's say that you end up playing, this person plays this person plays this. Lithium has 3 electrons as a non-ions, no charge, and helium is 2. This person would get both cards. Let's say they play another card. Let's say this time H versus B +2. Hydrogen is 1, beryllium is 4, but with a +2 charge, you lost 2 electrons. 4 minus 2 is 2. 2 happens to still beat hydrogen, so that person would win that one. Let's say that we have titanium, and again, there's a big container full of these, as you guys saw. We're going to pull at random. Let's see what happens. Oh, dang, we got something decently close. Nickel. Well, nickel is 28. Titanium +4, that's 22 minus 4, that's 18. The nickel wins. And that's literally what you do back and forth, just like the game of war. Now, what in the heck happens if there's a tie? Well, let's say there is a tie. I got 2 aluminums with a +3. 10 and 10. 13 minus 3, 13 minus 3, 10, 10. Well, just like any war game, the way we're going to play, okay, I know this might be different, you would put 2 down. And then you would reveal the next one. So in this case, chromium, as I fixed the camera, I apologize, it's 24. Lithium. Well, chromium's 24, lithium is 3. All of these go to this person. So that's what we're going to be doing, is a quick little review of electrons here. Obviously, we can't play each other, okay? It'd be, a pretty fast game. Looking, how you would normally do this in class, for those who are wondering, is this. Everybody would grab a set of 9 here, and they would grab 21 cards from that bin. They are a bunch of different atoms and ions that have been mixed together. A whole bunch. Shout out my students who helped me cut these out last year in 2020. And you build a deck of 30. Because it's 30 and not 52, this game actually goes a lot quicker than what you might think. So I'm going to end it there, and we'll do a few different back and forths of the game. There's going to be different ways I'm going to ask questions on electrons, and we'll see how that goes. Thank you so much.